Then we have there's a drivetrain and a motor that drives these, and these things are all electric driven. And right here, generally, they have a motor right in the middle, right here. Wires coming down the span, dropping down at each tower. We have a wire cord dropping down to a motor. And you know, the average motor is only about 1 horsepower. It's amazing what 1 horsepower can do if you let it develop enough torque. And it has no problem driving one of these units around a field with 1 horsepower on each tower. Yes, Bob?
Very few water drives.
Yeah. There is the rare exception out in the field of water drives. But, and I think you can even still buy them today, not that they're selling any, but I think that they are available. I think Wade still manufactures a water drive if you would like to buy one. Yes, there's some old antiques out there that are water drive. But anymore, probably 99+% are electric drive. And there's some hydraulic drive as well. That, I shouldn't say 99%. There is a manufacturer called T&L that manufactures a hydraulic drive run by oil. And they have oil lines running down, and they have orbit motors at each of the tires and drive them with hydraulic orbit motors. So that is another option that's out there. But it doesn't take a lot of horsepower to drive one of these around the field. They do have them as low as 1/4 horsepower. And the biggest ones, some of the older machines that there was a variety that used to run a 2 horsepower motor, but what they call the high-speed option generally is about 1.5 horses. If you want a real high-speed one, that'll run faster gear ratios. And so that, somewhere in those, you know, between 1/4 and 2, you're going to find all of the different motors fall into line. With a 1 horsepower as the standard. Or even now, maybe 3/4 horsepower is the standard. They get the new gear drives, new developed gear drives that they have. Again, we're not talking very fast. You know, 10 to 20 hours maximum revolution time. The high speed, about 10 hours to make a 1/4 mile long circle go around. And it takes a normal speed about 20 hours. Tremendous amount of torque developed so they can walk up, like we said, farm equipment. They'll just walk right up it. You park it in the way, it'll figure out a way to climb it. Those tires will just start digging in, and it'll finally work its way up it, if it doesn't safety kill ahead of time. Now there are, we'll get to the electrical here in a minute, and that is next. The electrical system, wire has to come to this center point. So we have to bring wire in underground. We obviously can't put a pole line out there because we got to walk this machine around the field in a circle, so we got to bring in buried wire. And these things run 3-phase. Must have 3-phase to get the ability to auto reverse. Plus, it also is more efficient. The motors cost less for the same horsepower. And the higher the voltage, the more efficient it is. And so we run it at 480 volts, 3-phase. So we do have some relatively high voltage. So there is definitely a danger of shock when you're out working on these, and that scares most people away from them, which is good for the technician because that gives us jobs, you know. All those guys in irrigation tech, that's instant jobs. Got to go out and keep these things running, and most people are afraid of them. Well, great. We'll learn how to work on them and go out there and do it for them. It becomes a very specialized trade. There are not a lot of people in this world that work on pivots. And most of the problems that you get on center pivots are not electrical. They're mostly mechanical. The dang things get stuck in the mud is probably the most common problem you ever get, you know. The real mundane. The flat tires. You don't think about flat tires out in that field and say, well, how'd they get a flat? Well, we try to run them at such low pressures that occasionally they'll roll off the bead. Because these towers are always trying to go straight, and you're making them curve. They don't canter those wheels so that they're going around in an arc. They make them go straight, and then just the anchor back here, this big old concrete anchor's making them skid into place, and they're being pulled straight. And so they're always trying to skid sideways, and occasionally they'll roll the bead off of the tire and you get a flat tire.